Now, before we get to part B, let me just say that I made a little mistake here because what I did is I combined x1, I combined this term with this term. Well, actually, this one doesn't have an x1, so you can't really do that. What you want to do is have the 1 over 50 here and then add a forcing function with 0 and 1 here, because 2 times 4.5 is 1. Now you see that this is a non-homogeneous system, and in B they ask us to solve this with the method of undetermined coefficients. So the first thing that we want to do to solve this is we look at this and we solve the homogeneous system first. So x sub 1, x sub 2, these are both primes, and minus 3 over 100, and 1 over 50, and 1 over 100, and negative 1 over 25. We close this, x sub 1 and x sub 2 here, and this is the homogeneous part. So how do we solve this? Well, to solve this, all we have to do is solve for the eigenvalue, which is minus lambda, 1 over 100, 1 over 50, negative 1 over 25 minus lambda. All of that equals 0. So the vertical lines indicate that this is going to be, we're going to find the determinant of whatever is inside. So that's going to be negative lambda plus 3 over 100 times lambda plus 25, 1 over 25, but there's also a negative here, minus 1 over 100 times 1 over 50. And all of that is going to be equal to 0. So let's see. I can cancel out the negative ones, and then I can say lambda squared, lambda squared, the sum of these two, well, that was 4 over 100. So that's going to be 7 over 100 lambda. The product of these two is going to be a little bit large, 2500, well, small. And then here we're going to have minus 1 over 5, 0, 0, 0 equals 0. Now, if you actually put this in MATLAB, you'll get for lambda 1 equals lambda 2. Actually, you get two different values. So you get lambda 1 is equal to negative 1 over 20, and lambda 2 is equal to negative 1 over 50. With associated eigenvectors, and you can use the Jordan to find these, of 1, 2, and of 1, 1. Well, now that you have this, you can easily write the complementary solution by remembering that it is equal to x sub 1, the linear combination of the two solutions. And I should probably not use x, or if I do, use capital X, because we just used x for the other functions. So the complementary solution is going to be c1 x1 plus c2 x2, which is going to be equal to what? c1 times k1, which is the vector negative 1, 2, times e to the negative 1 over 20t, plus c2, vector 1, 1, times e to the negative 1 over 50 times t. This is going to be your complementary solution. Now you want to solve for your particular solution. So to solve for your particular solution, I say this. I'll show you how to input this stuff in MATLAB, and we'll keep going from there, because it seems like it's gonna get computationally non-justifiable, I would say, to not do it in MATLAB. You can do it, but if you have MATLAB as a tool, why not use it, as long as you understand what's going on. All right, so I'll see you there.